recording officially started. Happy Garbage Day, everyone. Yeah, welcome.
Yeah.
It's Tuesday, a nice wet and rainy garbage day, which is a good thing for those of us who have grass that looks like crap, and we're, hoping that it looks less crappy soon. Exciting morning at our house today. We had radon mitigation, which is when they drill a hole in your basement and put a pipe there to let dangerous gas out.
Yes.
So my basement is safer now. Next time you get to visit me virtually, I'll be less, infected? What's the word? Exposed. Okay, I'll take that. Yes. Excellent. So that's the exciting part here. But while I was listening to the construction, I got a chance to read through all of your formative assessments. And thank you for your efforts on that. It looks like it would be useful to go over it in some degree of detail, because there was sort of a bimodal distribution of folks either like using the slides and sort of saying my words back to me, or as the alternative, like, not sure about this. Can we go over it? Yes, we can go over it. So this stuff is very tricky. It really is. I mean, you're not imagining it. It's like, why is this so hard? Because it's counterintuitive, and it is difficult. The next thing you have to do, though, is get some practice with it. So homework 2, yes, I know, right? What you were hoping for. Homework 2 is now available. It's due Wednesday of next week instead of Monday, since we're back a day. And I'm expecting this stuff to last possibly through Thursday, so we'll have to juggle the rest of the schedule once we get that point. But homework 2 is not bad. There's very little in terms of like coding. It's mostly vocabulary review, and some of the questions are straight out of homework 1. So if you missed it the first time, get it right the second time. Fair? Yeah, and it's cumulative, so there may be some things where you need to refer back to earlier examples, but everything that you need is in example 3 for this homework. So I'll let you get started on that as you wish. In the meantime, we can talk about our formative assessment number 2. I did update grades this morning too, so you should be able to log in and see how things are going. It's too early to panic. I'll just tell you that. Everyone's fine. Everything is fine. So question number 1 here, in a 2-level model for persons nested in clusters, what is the purpose of level 2 predictors in level 1 predictors? So let's first talk, what kind of predictors would we call level 2 in this design? What are they?
Like an aggregation of the level 1 predictors.
That could be it. So if we take the cluster mean of a level 1 predictor, that becomes a level 2 predictor. What about straight up level 2 predictors that just come that way? What would those be?
They're like group level things. Like they describe a group, not necessarily the individuals within the group.
Yes, group level things or cluster level things between cluster predictors from the chat window. Yes, indeed. So characteristics of the cluster. So if the cluster is a school, school measures of, oh goodness, I don't know whether it's public versus private or magnet or not magnet. Rural, urban was in homework 1. I made that one up. Things like that, to where it would be a constant for all persons in the cluster. So if that's a level 2 predictor, our cluster characteristics, which can either be measured directly at the cluster level or aggregated up from the people, because cluster means are also level 2 predictors, what is their purpose in the model? What kind of variance are they trying to explain? It's a forced choice question here. Level 2 or level 1? Finger question. Level 2 or level 1 variance is what level 2 predictors are trying to explain. 2, yes, not a coincidence. They're trying to explain residual variance or random intercept variance. Random intercept variance. So note in the homework, there's some bad distractors, right? I have impossible combinations like level 2 residual variance or level 1 random intercept variance. I did that on purpose. Technically speaking, level 2 residual is what other textbooks might call it, but I'm not doing that to you. I'm staying consistent in my terminology. So level 2, random intercept variance, reasons why clusters differ from each other in their means on average. That's what level 2 predictors are supposed to do in terms of their main effects in the model or interactions among level 2 predictors. Okay, good so far? Yeah. All right. Level 1 predictors then, what kinds of variables are they in this type of design?
Person characteristics.
People things, yes, things that vary within clusters, and that means they almost always vary between clusters too. But when you put a level 1 predictor in the model, what kind of variance are you trying to explain?
Level 1.
Level 1, which is random intercept or residual?
Residual.
Residual. It's between or within?
Within.
Within. Inter or intra cluster variation. There's a new one. Intra, within, yes. I can think of 6 different ways to say that. You pick the one that you like the best and roll with it. The easiest, though, is to think of it as if it's measured per person at level 1, it predicts the corresponding variance in your outcome that is people variance at level 1. There's a direct symmetry there. Good. And the same would be true for level 1 interactions. So interactions among level 1 predictors would account for level 1 residual variance as well. Interactions of a level 1 predictor with a level 2 predictor, we have not talked about yet. Those are called cross-level interactions, and that is coming in the next unit. So I've deliberately not done that.
In the next what?
Units. Unit. So lecture 4 and example 4. That's my unit term. Yes. All right. Excellent so far. All right. Now comes the tricky part. If you use cluster mean centering for a level 1 predictor, what do you get? How does one interpret the fixed effect for the level 2 mean? And do they change if either predictor is not included? So I wanted to build a spreadsheet for this because I found this to be a useful exercise in the past to try and make this a little bit more concrete as opposed to just vocabulary salad. So we have level 1. Well, it does get to be kind of ridiculous, right? The cluster mean, no. So cluster mean centering is a choice for how you make your level 1 predictor. So the way that I name these things is WC for within cluster. And if I have a predictor that's X, what do I do to create my new within cluster mean-centered version of X?
Minus the mean. Cluster mean.
Yeah, minus the cluster mean. The alternative, if I had constant mean centering, or constant centering rather, or grand mean centering, whichever term you want to call, I would use this as just like, I'll call this level 1x. Is that confusing? Yeah, maybe. Who knows? Is x minus what instead?
A constant.
Which one?
Anyone?
It doesn't matter. Minus. Yeah, we can also say grand mean. Does GM work for this instead of CM?
Yes.
Yes. By the way, Nikki, you might remember this from being in this class 2 years ago. I used to have people in groups, and then when we got to grand mean centering versus group mean centering, and they both had the same initials, that was very bad. So that motivated my use of the term cluster, so that G only stands for one thing at a time. Okay, so the difference in terms of the model that these questions 2 and question 3 are asking about is basically how did you make your level 1 predictor? Did you subtract a variable, which is the cluster mean, or did you subtract a constant? At level 2, I usually have a variable that's like cluster mean. Let me put some x's on here. Cluster mean x. Some x's on here. We may need other letters here. Grand mean x. Okay, so this is going to be the centered version. I would make this as the original cluster mean minus some number, right? Doesn't matter what it is. There, so I would need to save it as a new name, but the idea is that you're just moving it over by a constant. Now, if I'm using the other way of setting up the model, do I change anything?
No.
No, it's the same variable at level 2, either way. The question is, what do you get back? And what are you assuming about what's not in the model at each step? So question 2 said, if I put this variable in the model, how do I interpret its slope? I'll give you the choices down here. Your 4 choices are within, smushed, between, and contextual. If I put in this within cluster centered level 1 predictor all by itself in my model, which of the 4 do I have? Within, correct. So that's the idea of, yeah, pound it out, yeah. That's the idea of when I'm teaching longitudinal, I say more than usual. In this class, it's going to be more than your peers. So having a relatively high value of X relative to everyone else in your cluster. How does that translate into a different outcome for you relative to your cluster? So relative to your peers is the key idea here. Relative to your peers, the coefficient for the within slope tells you the change in Y for a 1 unit change in X relative to the cluster mean. So if you have a score of 1, you're 1 higher than your mean. If you have a negative 1, you're 1 lower. Now, what are we assuming? I'm going to put this in parentheses here, about the corresponding level 2 effect if it's not in the model. This is not a question I asked on the quiz, but we're going to go through this step by step. What am I assuming about the level 2 effect of X if I leave it out of the model? There is none. So I'm going to put 0 in here, because if you leave out a slope, that's usually what you're saying. Its slope would be 0. Okay, with me so far? Hey, I wanted my parentheses. It took it away. What if I just put a bunch of stuff around it? Make it look like a happy face or something. Then can I do it? No.
Lisa,
Okay,
put,
try that again.
did it work? If you put the little, you know where the little squiggle is for distributed across an R?
Yeah, maybe?
So that little like apostrophe, if you put that before, I think it'll retain it.
Yeah, it worked,
But
and then
don't
it just
click on
yelled
that.
at me about inconsistency in my formula or whatever.
Oh.
Okay, good enough. Thank you.
Yeah.
There. So, recapping. If I put this predictor in the model, it's the within slope. Could it be something else? No.
Out of context, no.
No. This will always be what it is because that's the only information that it has left. The variability in this predictor is only within level variability, therefore its effect in predicting an outcome can only be a within effect. Some folks in their answers seem to have a confusion with respect to this idea versus the intraclass correlation of the predictor. So the intraclass correlation of the predictor sets up the logical possibilities for what role it can play in the model. If I have a level 1 predictor with intraclass correlation that is below 1, it has at least some within cluster information to it. That is a limiting condition for it having a relationship to the within cluster variation of your outcome. It has to have variance before that variance can correlate to other stuff. So if the intraclass correlation is less than 1, you could have a within effect. If the intraclass correlation is greater than 0, you could have a between effect, but not necessarily going to have one. Having variance at each level is a logical prerequisite to having a slope at each level. So what we've done in cluster mean centering, or variable centering more generally, is subtract out the mean of the cluster so that what is left is purely relative peer-to-peer variation in X with respect to within a cluster. Okay, with me so far? Any that you want to hear again or hear differently? Okay, all right, I'll keep going. Next one. What if we just put in the cluster mean all by itself?
Between effect.
Yeah, here are your 4 choices again. It's between. The only information in this predictor is between cluster information. It is the aggregate over level 1 units, so level 1 variability is gone. Therefore, the only possible effect it can have is between. Now, what are we assuming about the within effect if we leave it out of the model? That's nothing. Yeah, same here. I'm just going to copy this so it doesn't yell at me. No, I don't want help on this error, thank you. What if I put them both in at the same time? Could I do that?
Yeah.
Sure I could. What's the level 1 slope going to be?
Within.
Within. What's level 2 going to be? Between. The end. So even though folks are often interested in contextual effects, from the perspective of not screwing this up, this is the easiest. You set it up ahead of time. You know what it means. You know the result of any omission is that you're assuming it's not there. To me, that is the cleanest. So what kind of pseudo R square would I be looking for an effect size of the within slope?
At level 1.
At level
Zero
1.
variance.
The residual variance. The within slope should account for a reduction in residual variance. That means the between slope should be doing what? The other one. Yeah, level 2. Level 2 random intercept would be the pseudo R square effect size for that. So the reason why these do not change their interpretation when they're together versus separate is because these two predictors are uncorrelated. They will always be uncorrelated unless you have issues with missing data, then they might render a slight correlation, but if you do it properly, they will be uncorrelated. And that means it doesn't matter whether the other variable is in the model as a predictor, they don't compete for variance, they each stay in their lane. So if I were going to get all Venn diagrammy on you, so let's say that I have my big circle of variance here. I'm going to cut it in half. And this is level 2. And this is level 1. And no, I don't have a fancy iPad pencil, but I make paint work. Because I'm old, damn it, and this is how I roll. Paint was the first program I learned how to use when I was like 8 or something, so yeah. All right, so if this is my piles of variance here, cut it in half. It's like I've got my within box, within cluster, and then I've got my cluster mean box, and they each stay in their lane and eat their side of the variance here. Now the tricky part. If you're doing constant centering instead. So first question, what kind of information is in this version of the level 1 predictor if all I did is subtract a number from it?
Both.
Both. I haven't changed it. So think about the outcome that you're predicting. You could subtract a number from it, but we don't typically do that. You didn't do anything else to it though, right? It has both, and that's the whole reason that you're using a multi-level model in the first place. Just because, in my mind, this is a predictor and not an outcome, it's still the same issue. It is a multi-level problem. So if I ignore that and I just stick it in the model all by itself, centered at a constant so that the fixed intercept means something, which of the 4 effects do I get here? This is smushed, otherwise known as?
Conflated.
Conflated?
Convergence.
Convergence, yeah, pick your term. But the point of the story is that this is the smushed effect. And more to the point here, bring down these headers for a second. The smushed effect says what about the level 2 predictor that is missing? Are we saying that it's 0 in terms of what its slope would be? No. What are we saying?
We are assuming that's equal.
It's equal, and this is the problem. You are putting a level 2 predictor in the model without realizing it. So what you're saying is that the within slope and the between slope are the same. They're one number, and that number is the smushed coefficient. Most of the time, the smushed coefficient will be very close to the within slope because there's relatively more information, and it sort of drowns out the signal of the level 2 between slope. So the problem really boils down to a misspecification in the level 2 model, not the level 1. So this is not good. What about this column here? If I just put in the level 2 cluster mean, what do I get? Here's a hint. Yeah. Is there anything different about this cell and this cell, if that's the only predictor in the model? No. So that's what it is. It's between. And what are you assuming about the level 1 slope then, if you don't put anything in for it?
0.
It's 0. In terms of effect size, what should the smooshed coefficient be targeting? Tricky one.
Like, what do you mean?
Like, which of my variances should go down if I put in a smooshed effect?
Residual variance.
Residual variance,
However, both will be reduced.
both potentially. Yeah, because you're putting in a between effect and you're putting in a within effect, and you're saying they're the same number. So that would reduce both variances at the same time, except in the very unlikely situation in which the effects are in opposite directions, in which case you could actually make one of them go up, but that's pretty rare. Now, what about when you put them both together? This is the tricky part. So we said the level 1 predictor has both level 1 information and level 2 information in it, right? The level 2 predictor has only level 2. So if we think about this from the perspective of regression and unique effects after controlling for other predictors, what is unique in terms of what level 1 provides? Just the level 1 info, which means this becomes a within slope. It's been fixed. So you end up at the same place of having the level 1 slope correctly specified as within and accurately targeting level 1 residual variance, even though the variable that they are multiplying is different in each strategy. You end up at the same place. Now that might make heads hurt. It makes my head hurt a bit. But I think the difference in why this seems so strange is that when we fit regression models, we don't ever have access to the variable that has the unique information, right? Like we have age and we have SES and we have demographics this and demographics that, it's all controlling for each other, right? But we don't ever have the purified version of that variable to stick in the model. That's what we're doing here in cluster mean centering. It's like we're residualizing it against the other stuff. We're creating a version that just has unique information. So the slope that these variables have is the same, even though the variable that's being multiplied is different. Now that is going to have implications for how you would show the effects of these slopes, which is why I added a bunch of new figures to the end of example 3 last week. So hope to get to that by the end of this week. Okay, so within is okay both ways. Now what is this thing? There's only one left that we haven't used so far. This is the context effect. Yeah, contextual or context effect, you choose. This is the idea of incremental. After controlling for the original level 1 predictor and all of its information, what is the extra benefit of the cluster you belong to? The way I like to explain this, and I wish I could remember who said this because it wasn't me, but I stole it. Picture moving somebody to a new cluster. How would their score change? That's the contextual effect. Because when they move, they bring all their stuff with them. The good news is you can get either the missing one from either model. So up here, if I'm doing cluster mean centering and somebody wants the contextual effect instead, it's between minus within. As a linear combination, so a -1 goes for the slope for the within variable, and then a 1 goes into the slope for the between. Down here, if I want to get the missing between effect, it's within plus context is the missing between. Why did it do that? There we go. So at this point, the models are equivalent. They're just rearrangements of each other. It's like 6 of one, half dozen of the other. Now, what you want is a different question. So, Kendall, I think you had mentioned this in your answer. Am I remembering that correctly? About, I think you had written, don't we want the context effect? Like, isn't that the thing that we would usually interpret? Something along those lines? Yeah, and I've gotten into arguments with people about this, and the conclusion that I've drawn at the end of this is you want whichever one you want, just make sure you interpret it the right way. That's the thing. So some people, the between effect, it's weird to them because it's partially redundant with the level 1 information, and so they're thinking of it, well, how do you get to be in a cluster that has high X? Because it's filled with people with high X. So it's not really a cluster thing.
Except that you don't know the causality, right? So like you have to be careful about how you interpret that.
Yes, I will never use the causal word in any of my analyses. I just don't live in that world where I would have strong enough evidence to say anything is other than just associated. But the context effect really is the extra that fills in the difference. So like if I have an R square for my level 1 variable, and then I have an implied R square that goes with it when I have the smushed effect, the context effect is going to pick up the difference to get the R square for the intercept up to where it should be. And we'll see that in the example that I have. So between effect, not controlling for individual predictors. Contextual effect is controlling for individual predictors. Yep. Between effect is not controlling for the individual predictor. The context effect is controlling for the individual predictor. There's a picture that goes with that idea. That is this one. I like this one. I think the Venn diagram one's going to get too ugly if I try that. So this one is the idea here. The level 1 predictor, when you use constant centering or grand mean centering, still has both the level 2 part and the level 1 with 1 part. So its slope does partially account for the random intercept variance at level 2, even though it's a level 1 slope, because it's the between part of it that's doing it. However, to the extent that the between slope is different than within, context comes up here to fill in the gap, to get to the rest of what it should be to get to the full between level relationship. Part of it is implied by the level 1 already. So context is like, what is the extra impact of the people around you, essentially, after controlling for you? All right, made it through question 3, I think. Not what I wanted, where'd my spreadsheet go? There we go. Okay, how are we doing? A little better?
Can
So-
you make the spreadsheet available?
Certainly. Yeah, I'll
I think
save
it
it
might be
and I will
helpful,
post it on today's spot. Yes, I don't normally do answer keys for quizzes because I want folks to come up with their own answers, and there's a lot of variations on right. But things like this that we build in class, yes, absolutely, I can post. Although I have to fix the little green thing because it's just going to bother me. Now, examples from your own research. Who wants to play? Okay, Hillary, I said I'd call on you, right? I warned you.
Yep, you did. Thank
So you have a good one. What's your example?
you. Yeah, so my example would be looking at the relationship between English and employment outcomes. and so with refugees. And so you would have some individuals who are just gonna learn English faster and or better than other individuals, right? And that would be like our level 1 within stuff.
Mm-hmm.
And then there could also be different schools that might do a better job or not of teaching that could also cause some differences, and that would be the level 2. And then the contextual effect would be like moving the same person to like a different school, and like what would that change for them?
So repeat it for the recording. The idea was groups of refugees learning English, and they're learning it from different schools in different places. And some schools might be better at teaching English, and some people might be better at learning it. And if you take somebody with whatever ability that they have and move them to a new school, that's your context effect. I like that one because it really, like, you can picture, like in a language classroom, you might have to pair up with people and talk to them, right? So the level of the people you're talking to probably has some extra impact on what's happening in the classroom than beyond just your own abilities. So just like this, right? We're all learning from each other. You're like, no, we're not cheating. I didn't say that. We're all learning together. That's what we're doing. Who else has a good example that they want to share? Want to try? Go for it.
Sure. So, fair amount of kids have autism, and then within the groups of the kids who have autism, some of them are going to have access to more interventions like behavioral services, programming, medication than others, even when we account for location and the socioeconomic status of their families. And then additionally, so that'd be like the within effect.
What's my variable? So we have kids with autism that are grouped
So
into,
I suppose,
can we do clinics?
sure,
Care
yeah.
systems?
Yeah, that works.
Something like that?
Clinics, yeah.
Okay, clinics.
And then, oh God, where was I? So,
Go ahead.
so yeah, out of the kids with autism, you're going to have access to different things, like services. And then also, like, within those groups, they're going to be placed in different clinics as well, because you're not going to have one clinic serve everyone. So between the clinics, there's also going to be differences. I don't know. That's what I got.
So if you think about a level 1 variable, then that would potentially have both. Are some clinics going to have children that have different types of I guess, problems or symptoms, however you want to phrase it?
Yeah.
Things that they would be receiving care for. And so do you think there's a difference in outcomes for a patient if they are in a clinic with other similar patients?
Oh, yeah.
Maybe that clinic has more expertise in addressing certain kinds of issues, and so people choose to go there? Yeah, context, beyond just the individual. That's the idea, yeah. So I think in trying to come up with like ways to explain this in papers and such, keeping in mind what things are relative to is going to be helpful to your reader, because otherwise it gets real confusing if you have all these different effects of the same predictor and different versions of the predictor. So more than your peers, more than other clinics, that kind of idea. One more than your mean, more than usual, that is the within. Any kind of words that you can use to hang on to that. Whereas, clinics who have more than other clinics. Clusters, groups, whatever you have. All right. Any other examples or questions, comments?
I don't know where my idea project falls in, but I have, levels of, like how items function differently within a group of people versus between groups of people. But that gets into IFA, which I know is.
Yeah, that's sort of heading out of territory.
Yeah.
But I will put in a plug though for any of you who've done like structural equation models. Psychometric models. What would happen if you tried to do that on clustered data? Could you? Please don't make me. Yes, you could. You would have a between structural equation model and you'd have a within structural equation model. Yeah. Same exact premise, even at that level of complexity. And you could have between factor loadings and within factor loadings, and they don't necessarily have to be the same. Jonathan and I taught a workshop in Germany this past summer on multi-level measurement models. That material is actually on his YouTube channel, because we were using his device. So if you're interested in that, have at. We spent 3 days building up to that, though. The first 3 days were like psychometrics, cluster data, and then multi-level psychometrics. So, good fun. All right. I will put this up after class, but if there's no more questions, we can sort of head back to the example. Keep working on how to make Stata and R and SAS do our bidding for us. Yeah, so I don't remember where we left off, but I know that we had gotten through the empty models for sure. So in terms of the story with this, these are students in schools. We're predicting math from a variety of things. And the intraclass correlation for math as our outcome was 0.18, so 18% between. We have a quantitative variable for SES that's obviously fake, and it has an intraclass correlation of 0.27, so 27% between. And then we also had a binary predictor for whether or not the student identified as non-white, and that intraclass correlation was 0.63, so much higher. So what that means is that there is a possibility for both of our predictors, SES and non-white status, to have a level 2 effect because they have some level 2 variance. There's a possibility for them to have a level 1 within effect because they have level 1 within variance. We don't know what those effects are yet, but we know it's possible. Okay, did we do this model, 2A?
I don't think so.
You don't think so? Okay. Well, if I don't remember it, then that's not good. So I'll just assume we're going to re-go over it if we did it before. So the variable that's going in to the level 1 model, and I'm doing this in pieces just so you can see what happens. In practice, I would typically, if I'm doing cluster mean centering, I'd put in both halves of it at the same time. So cluster mean centering SES minus the cluster mean of SES. So note the subscripts here. Why do I only have a C on this one?
Because it's only the cluster mean.
It's the cluster mean. It's a level 2 predictor. It varies over clusters only, whereas the original predictor varies over people and clusters. I'm giving it a fixed effect for now. We did talk about this because I asked Erica about this and she answered. Now you're like, I did? Yeah, you did. Next week, we're going to have a U here, but not today. That's called a random slope. Right now, all we have is a fixed slope, meaning all the clusters get the same. So that is a variable that I made ahead of time. You'll get a chance to practice making such variables in your homework. I throw it into the model by itself in SAS, or SAS data and R. I'm only showing R output at this point because the Stata output looks quite similar. So we have our school variance in math. We have our student variance in math within schools. 12 is the expected math score for what kind of student? What does 0 mean in my predictor?
That's for a student at a regular, well, at a school SES level.
It's when you're at your, 0 means within centered. So within cluster centered, 0 means you are at average SES for your school. We don't know what that is yet. It's not in the model yet. So this is purely the idea of more money than other kids at your school. That's what this variable means. SES. Can I say money? Money is easier to say than SES. I'm not a sociologist, so I'm just going to like mix words together. That's all right. Money is power. Math is money, and money is power. Therefore, math is power. Can we do the transitive property of,
We'll take it.
yeah.
Is there a pun in there too? I don't know, but
There, it sounds like there could be, certainly.
the sociologist will allow you to substitute that
Okay,
temporarily.
thank you.
As long as
Yeah.
you don't do it in your papers.
Fair, fair. I don't write like I talk in my papers most of the time. I try to do, put on my professional Lisa hat. But, I keep it real in this context. I give myself a rim shot on that one. All right, the slope of our new predictor then, 2. Y goes up by 2 for every unit what?
SES.
Money or SES, but more than what?
Your cluster mean.
More than your cluster mean. For every unit, more than your cluster mean. Relatively more money. Is this within cluster SES a level 1 predictor or a level 2?
1.
1. Is it a people thing or a cluster thing?
People
People. So which variant should it have explained?
receiving variance.
Lo and behold, yes. It explained about 5% of the residual variance. By the way, these boxes are from SAS output, from a little function I made, but I like them because they show all the numbers in the same place. Jonathan's result of his function is right here. So note it is relative to the empty means model as our baseline. The empty means model has as much variance as there is to be explained at each level. So that's our jumping off point. And this random intercept variance went up a little bit instead of down because we explained 5% of the residual. I typically wouldn't bother to report that. Okay, now if we add the missing part, we did talk about this, but it's good to go back over it. Heady stuff. Now we're adding in cluster money. Mean SES for the cluster as a new level 2 predictor and giving it a separate slope. And I have the -0 here to remind you that if your level 2 predictor doesn't already have a meaningful 0, to make it 1 by centering. So we throw in the new cluster mean SES variable paired with the original within cluster centered variable. So which part of my table are we in? Are we in this part? Are we in this part? 3, 4, or 7, 8?
3, 4.
We're up here. So I did this, and now I'm jumping over here. So intercept still around 12. It's now doubly conditional though. It is for a student who has average money for their cluster. And in what kind of cluster?
An average cluster?
Yeah, it's 0 is close to the average for the variable. So it's a cluster mean of 0. And whatever scale of SES is a z-score. So doubly conditional. The coefficient from our previous model was 2.19117. It is 2.19117. Surprising? I'll try a new one. Surprising or not surprising? That it's exactly the same. Not surprising, because these predictors are uncorrelated. They stay in their lanes. So this one is the same number, it means the same thing. For every unit more money I have than my cluster, my mass score goes up by 2. For every unit more money, what's the end of my sentence here? For the second one, the level 2 slope. Then what? For every unit more money my cluster has.
More than other clusters?
More than other clusters, that's it. Whose score goes up by 5? A person or a cluster's?
Clusters.
The clusters, all the people. That's the distinction that I'm making. It's like a rising tide lifts all boats, that expression. The whole cluster gets a boost of 5. So even if you're poor, you go to a rich school, you get your boost. Than other clusters. So within cluster is you relative to your peers. This between cluster effect is your cluster relative to other clusters on average. And if reviewer 2 says, hey, I don't like between slopes, I want a contextual slope, what do you say? Okay. Do I need to rerun a different model? Because I could, right? We established that we're here right now. If I want the context effect instead, I could move down to this version, or do that. So between minus within is the context effect. The code for that in R is contest 1D, right here, this little thing. These values are multipliers of the slopes that are obtained from the model. So 0 means don't use the intercept. Then minus 1 means multiply the within slope by minus 1, and then add to it the between slope times 1. Works out to be between minus within. The analogous data code is right here in this lincom, which I wrote in the same order to keep it consistent, although you could write it as between minus within more directly. I am also, by the way, saving predicted outcomes from this model to compute total R-square, which will be at the end of the handout. So the contextual slope is 3.67. That is 5 minus 2. That's where that came from. So 3.6 is the boost that you would get if you take yourself and go move to another school. So whether you're interested in the between slope that is 5.8 or the contextual slope that is controlling for the level 1 information as 3.67 is up to you. So long as you tell your reader which it is and interpret it correctly. So 5 is not controlling for individual status. The 3 is after controlling because the 2 fills in the difference there. In terms of R-square, our new predictor relative to the previous model is level 1 or level 2? 2. So what kind of variance should it be going after? 2. And lo and behold, it did. So we've accounted for 6.687 of the variance in as a proportion of variance in the random intercept. Level 1, exactly the same as before, at least to several decimal places. And in my SAS function, it actually computes the change in R-square. So each of these is relative to the empty model. This was an order of operations issue that some folks had on the homework. Pseudo R-square should be computed relative to the empty model for your current model, and then to get the change in pseudo R-square, subtract those two values. Otherwise, it doesn't work out, because if I did it as like this one versus that one, it'd be like, of the variance that isn't already explained, how much did I get? And that's a conditional amount as opposed to an absolute of this variance. Does that make sense? Order of operations. Relative to the empty model first, then the difference. So on the whole, 69% of the random intercept variance is because some schools have more money, and about 5% of the within residual variance at level 1 is because some kids have more money. Okay, are you with me? Okay, so if you want to be like, la 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 la, I'm just going to do cluster mean centering the rest of my life and I'm not going to learn the rest of this, that's fine. But I can't stop there. Now I want to show you what would happen if we went through the smushed effect. and how you can tell in reading people's papers that they have smushed their predictors and not realized it. So I have started with the new model here, Model 3A, that has one predictor in it in its original student SES, left uncentered because 0 is already the mean. So you could say that I've grand mean centered it at 0, whatever. I've given it one slope. So I have the previous solution to compare against up here in this little box, and I have my current solution. So intercept previously was 12.68, it's 12.65. Coefficient before was 2.19 for the within slope. This one is 2.3. Why is it different?
Because it's capturing some of the between.
It is estimated assuming that the between slope and the within slope are both 2.3. So it's not a coincidence that it's a little bit too high because it's being biased by that 5. It's like pulling it away from the 2.19 that it wants to be. Pulling it a little, not much. That's because there's way more students than there are schools. Like, how many students are in this example? A lot.
7,000?
Yeah, 7,000 students versus 160 schools. That's why the smushed effect is much closer to the within effect, but it's being pulled, and you can see that. Here we go. So if you see a level 1 predictor in a results section or in a table, and there's no mention of it being cluster mean centered or otherwise adjusted for the variance that it contains, and you don't see the same variable in the table at level 2, it's smushed. Here's another dead giveaway. The pseudo R-square from this model. My level 1 predictor accounted for about 5% of the level 1 variance. Very close to what it was before. I have the comparison in the little box here. It was 5.4% here, and it was 5.5 before. So it's actually down a little bit. It's not accounting for as much variance as it should because the coefficient isn't the right one. This is the right answer, where the within slope and the between slope are separate parameters. The correct answer for the within slope is 2.19. The version of it that this model is giving me is 2.39. So it's not accounting for as much variance because it's not the right answer. It's close, but it's not the right answer. Now this is not the part that I would expect you to be able to tell from reading a paper. Here's the dead giveaway. What level is this predictor supposed to be for SES? 1 or 2? What's it supposed to be? It's a level 1 predictor, right? And yet, my level 1 predictor accounted for 44% of my level 2 variance. That can't happen. Some kids having more money cannot explain why some schools are better at math. There's a logical disconnect there. What did explain the 44% is the between cluster variance that's hidden inside my level 1 predictor that's not obvious. But this isn't the right answer. The previous model explained 69.4%, and we're only up to 44%. Why is it so different?
Because the level 1 stuff is dragging it down?
The level 1 slope in this smushed model is the level 2 slope also. So the full effect should have been 5. This model's only giving it 2. So it's not accounting for as much variance as it's supposed to because the level 2 slope is too small. So I know what the level 1 within slope is supposed to be. It's 2.19. I know what the between slope is supposed to be at level 2. It's 5. both of those numbers are trying to be represented by this sole 2.39 for both. That's what a smushed effect is. So consequently, in terms of the variance explained, neither one is accurate. Level 2 is way too small because the coefficient it was given is way too small. Level 1 is pretty close, but still not right. It was 5.5% versus 5.4. Okay, how are we doing? Are we hanging in there? Hanging on to it? So point of the story, one number cannot do the job of two numbers. How's that? Fair? Okay. Something's got to give. The model is misspecified. And you can see this in practice if you see a table of results and there's a level 1 predictor that is not mentioned at level 2. Or if people talk about a level 1 predictor accounting for level 2 variance. It can't. It's the level 2 part of it that's doing that. So let's fix it. Model 3B. We're going to add in the cluster mean of SES at level 2. Now, we have moved from this column over to the both column, and things are going to change because these two predictors are correlated. Student SES is correlated with school mean SES. That means their effects are going to fight against each other, and we're going to get the unique effect after controlling for each of the others. So here is the same box with the answer key from what we got when we used cluster mean centering. The within slope is supposed to be 2.19 when it was attached to the within cluster version of the variable, even though it's now attached to a different version of the variable that has all the information in it, it's the right 2.19. It's the same number to 5 decimal places. In contrast, the same variable at level 2, cluster mean SES, now has a different coefficient. What's this one called? Cluster mean SES at level 2. In this model, when we are using constant centering at level 1, what is that level 2 effect? Between or contextual? This is contextual. After controlling for original student money, the extra benefit of going to a rich school is 3.67 per unit money. Without controlling for it, if the level 1 predictor only has within info, the benefit is 5. And if you've decided that you like contextual effects, and so you set up your model this way, have you smushed anything? No, this is fine. This is totally fine with respect to your fixed effects. And if reviewer 2 is like, but I like between effects better, what do we do? Cough, cough, homework question. Add them up. Add them up, add them up, up. My son loves Fall Out Boy right now, so that was light 'em up.
Yep.
Fire! Light 'em up. There you go, here's your between slope. The difference, the 2 ones in there. Add them up, and there's your 5. So let's look at the sequence of how the pseudo R-squares changed. So this column right here is based on the empty model. So we first put in the smushed effect. It picked up 5.4% of the level 1 residual and 44% of the level 2 random intercept. Then we added the level 2 mean of the cluster to unsmush the level 1 coefficient. and it picked up another 24% to get to the full 68% that the previous model had. So we end up at the same place. It's just a different way of getting there. But in terms of what is attributable to what, the increase of the 24% happened when we added the context effect to the model. That's its effect size. It's the extra part of the level 2 variance that the smushed effect did not get. So in all told, which effect is responsible for the R square at level 1? Within, between, or contextual? At level 1. Is it the within effect, the between effect, or the contextual effect of SES? I've heard all three. Okay, which of the three is a level 1 type of effect? Within, contextual, or between? Within only. Yeah, the within effect is responsible for the within cluster variance. Within cluster variance in SES is responsible for 5% of the within cluster variance in math. Level 2, this is the tricky part. You got two choices. You got between or contextual. Which is responsible for the full pseudo R square at level 2, between or contextual? Between. And the extra part that you get after controlling for level 1 to get up to the full? Contextual, yeah. Add them up, add them up. So yeah, had we left it smushed, our R square for level 1 would have been pretty much fine because the smushed effect was pretty close to the within effect. But there was more to the story. After controlling for level 1, there's more. The school you go to matters beyond your individual situation. Even the poor kids have better math if they go to a rich school.
So on this, where do the contextual?
I would argue that this is the effect size that goes with the contextual effect because it's the extra part that the level 1 predictor didn't already bring to the table.
And that's only for, we only like test that or see that on our output for the pseudo R square.
You would see that as the change in the R square from fitting a smushed effect to fitting the proper between level effect by adding the context effect. And in your homework too, I'm having you do it this way so that you can see it happen. All right. Okay. Any of that you want to hear again? Want to see it again? Here's another variable. Okay, now I'm going to control for student non-white. Here it is. Here's its fixed effect. Cool or not cool? In terms of model specification.
That's a smushed effect.
It's a smushed effect. But it's binary. How do I'm not going to cluster mean center a binary predictor. You could. But yeah, just because it's binary does not change the rules. This variable had an intraclass correlation of 0.68, as I recall. Very strong signal in terms of cluster mean differences and the proportion of students who identify as non-white at a given school. That's what the level 2 analog is. Proportion. It's like group composition when you have a binary variable. So if I add that in, it has a negative slope. It looks like, based on this, that students who identify as non-white have lower math by 2.7. But that assumes what? What's another way of saying why a smushed effect is broken? What are we assuming? The way I said it before is that the between slope at level 2 is equal to the within slope at level 1, but there's another way to say that. If I just put in student non-white all by itself, what am I assuming?
We're assuming there's not a level 2 effect.
There's not a level 2 effect. Which one? Because you're right, but there's two kinds.
Like not an additional.
Not an additional, correct, and the term for that is?
Contextual.
That's contextual. Additional is contextual. So this is assuming, without testing, that the proportion of students who identify as non-white has no incremental contribution. Another way to say that the between effect of this variable is the same as the within effect. And this variable accounted for a tiny bit of the random intercept variance and a tiny bit of the residual variance. So even though it is statistically significant, it is not a strong player. So if we fix it the same way. Yes, go ahead.
Sorry. So is that also saying, am I wrong if I say that it's saying the proportion of white versus non-white students is the same within each school for all schools? Is that what it's basically saying?
Nope, that's not the same thing. So what you said, the proportion of students who are non-white is the same across schools, would be an intraclass correlation of 0 for that predictor.
Okay.
Yeah.
Okay.
So that would be a logical prerequisite to even bothering to look at a level 2 effect. It has to have level 2 variance. That means the proportion of students who identify as non-white has to vary across schools for us to even be able to do this.
Okay. Okay, thank you.
Yes, thank you for the question. But I'm going to put in this predictor, proportion of students minus 0.3, because that was near the mean of it. Now, I could have left this variable uncentered, but that would make it weird. Now, why do I say that? Could I have a 0 in this variable?
Yeah.
I do, actually, in the data set. There are some schools where there are no students who are non-white. Can I show a level 1 within school non-white effect if I don't have any non-white children? I cannot. So it's weird to talk about it, that's why. So I centered at 30% so that there is, in terms of the reference school, the potential to show within school differences. So now the model is parallel in terms of having contextual effects for both variables at level 2. Lo and behold, opposite signs. The non-white effect is still negative and it's still significant. It's changed a little bit. It's minus 2.9, whereas it used to be 2.7, is that right? Yep, 2.7. Context effect is positive, though. What? They're in opposite directions. So I'm going to let you let that percolate for 2 days. What do I do with this? Is there a, what is the effect of this variable negative or positive?
Both.
Yes. Like, what? How can that be? We'll talk about that on Thursday, because it's 1:44, and I think we've had enough. Well, the room has had enough, even if you all are still begging for more. You'll have to come back next time for the exciting conclusion of how can the same variable have a positive and a negative slope. All right. Any other last-minute questions before we call today? All right. You should be able to do all of your homework 2. So feel free to get started on it or to procrastinate. Your choice. Due next Wednesday. Thanks for being here, folks. See you on the other side. Bye, Zoomers. Bye.